Good day, guys. This is first order differential equations from mathematics 96. So with first order differential equations, these are the key formulas that you use from your formula sheet to solve the problem. So you just arrange your problem to look like this. Then this other one will help you to solve. But before solving, there are a few things that you must take note with. So this is a law of exponent that we expect you to know, which means if I get e to the power in 5, I'll get 5, you can verify that with your calculator. If I get e to the power n in f of x, then I must use my law of log to take the n there so that I get that, just like I've done here. So this is the elementary knowledge you need to know to go through first order differential equations in math and 6, especially to handle this question. So that is it. You can now look at this problem, which says negative a half dy dx plus a half y minus e to the power negative x is equal to 0. So the first thing I have to do is I must arrange it to look like the first formula. So that means dx, dy dx, and must be on one side, followed by y, then that other term on that side. So I'm trying to make it to look like the standard form. So I get dy dx, negative a half dy dx plus a half of y is equal to e to the power negative x. So I'm trying to make it, arrange it to look like the first formula that we know from our formula sheet. So after this, dy dx must be made to be alone. So that means I must divide each term by negative half. That will take me to dy dx, then minus, because if you take a half divided by negative half, it will be minus 1. So that should be minus 1 times y. Then you divide that by negative a half, it will give us negative 2e to the power negative x. So here we are almost getting to the standard form, but we must know that for us to arrive there, the item that multiplies y must be a positive. So if I put it this way, plus, then this minus 1 will be like my p. If I'm following what the formula says, this will be my p. Then I go to my negative 2e to the power negative x, which is obviously my q. So from here, I've managed to arrange my problem to look like the standard formula. Then, to move on with the other formula, I will have to cut it bit by bit. You see the other formula as we've seen it over there. It's y e to the power, the integral of p of x dx is equal to the integral of q e to the power the integral of p of x dx, or the dx. So that is what the other formula that we use to solve looks like. So I always like to break this formula in a little bit. So I'll do that portion first, which appears on both sides. So since I know my p, then I will look for the integral of p, which means I'm doing the integral of negative 1 dx, which is negative x. So I'm done with the circle. Then from there, I go to this other portion. I'll use a rectangle for it. So the name given to this other portion is called the integrating factor. So if we call it IF, then IF is defined as e to the power the integral of p dx. So we've integrated our p dx already there. So it's just the integral of we'll just get e to the power negative x. So now if you look at what we've done here, this integrating factor has to be slotted on both sides of the formula. So if I go back to my formula, it means I've got y, the whole rectangle will be e to the power negative x, is equal to the integral of q. You still remember our q from the standard form, which is negative 2 e to the power negative x, then multiplied by the integrating factor, which takes the place of the rectangle. It's another e to the power negative x dx. So the left side, we're done. We now concentrate on the right side, where our negative 2 will go out, and if you multiply this, it's e to the power negative 2x dx. Then when you integrate, this will give us negative 2 into e to the power negative 2x over negative 2 plus C. So that is what we get there. So if you were looking for a general solution, then you will end there. But if they say a particular solution, then you have to concentrate and look for the value of C. So I'm just trying to simplify again. This will be e to the power negative 2x plus c if I simplify, since negative 2 will take care of negative 2. So now to get the particular solution of this problem, we need to calculate c using the conditions given to us. So you see the problem says we solve for x at 0, 3, 0 is the value of x, 3 is the value of y. So we're going to now substitute this information into the general solution. So it means where there is y, I'm putting 3, where there is x, I'm putting 0, is equal to e to the power 0 plus c. So we know that e to the power 0 is 1, so this is just like 3 is equal to 1 plus c, and that shows that c is equal to 2. And therefore, our particular solution means you copy the general solution the way it is, but in the place of c, we are now putting 2. So this is what we call a particular solution. So guys, that's the solution for that problem. We've solved our first order differential equation. So let's look at the next. We need to solve this equation at 2, 1. So again, this is your x and that is your y. So the first target is we must arrange our problem to be like the standard formula for first order differential equation. So that's our first target. So if we're doing that, we see that dy dx is already taken care of. Then all we need is the positive sign. And we've got a negative there. Then we've got p, which is a function of x times y. So now that I've got a negative here, all I need to do is to try to bring in the positive. So that negative, I will push it in to be part of that 2, so that I get it that way. That immediately shows me what is my p, and it will multiply y, just like you see the formula is showing. Then my q is already there, that side. So this is the first target in the first order differential equation format instance. So if I can write it like this, then I'm sure of my p, then I can look at the next formula, which is given to us in the formula sheet, e to the power the integral of p, which is a function of x dx, which is equal to the integral of q, e to the power the integral of p dx, then dx. So I have to move to the next formula now, which I always like to do it in little bits. So I will do this portion first, which appears on both sides. So I'm sorting out my p to integrate it. Integrating p, negative 2 is a constant, it steps out, I get 1 over x minus 1, which leads me to negative 2, the limit of x minus 1. So that's the integral of p. Then I move to the next part of the formula, which is what we call the integrating factor. It also appears on both sides of my formula. I've put it in the rectangle. So my integrating factor is e, the integral of p of x dx. And then you see we've done this portion already. It's right there, which is e to the power negative 2, the limit of x minus 1. And now this cannot simplify because of negative 2, so we need the law of log to move the negative 2 to the exponent. So this becomes e to the power the limit of x minus 1 to the power negative 2. This can now simplify to give us x minus 1 to the power negative 2, which simplifies to 1 over x minus 1 all that square. So that is the note I wrote on the other board, which I explained that as an N6 student, you must know how to simplify things like this. If you do this in your calculator, it's a simple 5. But if you do want to do this, if you apply a law of log, you see the 2 goes up, you get limit of 5 squared, which is again 5 squared. So if you put those things in your calculator, you just see that this has come out, which is some elementary information we need to know. So now we can go back to our formula. see the rectangle that appears on both sides, we will replace by that 1 over x minus 1 square, which is the integrating factor. So on my left side, I'll get y into 1 over x minus 1. Let's put it like that. Then we square this is equal to, on the right side, we need the integral of q, or q from the original equation is x minus 1 all that square, multiplied by the integrating factor, which takes the place of the rectangle, that is 1 on x minus 1 all that square dx. Then you see that this will take care of that. As for the left hand side, it reduces to y over x minus 1 all that square is equal to the integral of dx, as this one cancels. So it means we have y on x minus 1 all that square is equal to x plus c. So this is what we call a general solution. So from this general solution, we can now look for the value of c to get a particular solution by using the conditions there. So the conditions are saying where there is x equal to, where there is y 1. So if you do that on the left, you get 1 over 2 minus 1 is 1, square which is 1, is equal to 2 plus c. And that shows to us that c is equal to negative 1 if 2 comes there. Therefore, a particular solution means you copy the general solution, which is y over x minus 1 all the square is equal to x minus 1 in the place of c. And that is your particular solution. So thank you very much.